This is a topic that's dear to my heart, error handling. And the reason is that I think it has two parts to it. The first part is preventing errors, and the second part is handling errors. And preventing errors is a topic that's not discussed often, at least I don't see it being discussed often. And I see that handling errors is actually discussed more often, which is, in my humble opinion, less significant than preventing errors. Let's talk about preventing errors first. We could prevent errors in a number of ways. I'll talk about like why I think preventing errors is way more important, and it's actually going to be very obvious after we go through these. So to prevent errors, one of the measures that we can take is to perform null checks. And I'm just labeling this null checks, but I'm talking about checking against a null value, an empty value, or a blank value. Things like after you get some records from the database, you could add a decision element to confirm that you actually retrieved something from the database. If you're retrieving one record, confirm that you got one record back. If you're expecting to receive multiple records, confirm that you received multiple records. You could do that by adding a decision element after the get element. And in that decision element, if you're retrieving one record, you can check if it is null, true, or false. If you are retrieving multiple records, you can use the operator is empty, false or true, to confirm that you actually retrieved some records. Otherwise, there will be some operations after the get on these retrieved records, like display them on a data table or perform some operations on these. The operations are going to fail, the data table is going to be empty, bad user experience, probably the flow will crash. So it's a very good practice to perform a null check after the get and then control what the flow does based on that outcome from that flow. If it doesn't find anything as part of testing, you're gonna find out that it's not returning anything, and you can fix it. If it's not testing and it's user experience, you can control like what happens and notify the user with something, send an email, log an error, something like this. You can also perform a null check before you create an element. So before you use a create element, you've got a record, one record, or a collection of records that you are attempting to create. Before you actually create them, do something similar to what we did after the get. Add a decision element on the collection that we are creating or on the record variable that we are creating, and check if that record variable does have values. It does exist. It's not empty. It's not blank. Check that there is something that we are actually going to create before you do the create element. If the create is attempting to create something that doesn't exist, it's gonna crash. Same thing with before delete. Before we delete something, we perform a null check, and you can achieve this with adding decision elements before DML statements and after query statements like get. The second thing we could do to prevent errors is to validate input. We need to make sure that user either enter values or values are entered automatically, pre-populated. And when users enter values, we need to make sure that the values that they are entering are actually correct. Use things like default values. Get into the habit of giving it a default value. You might not give it if you don't give it a default value, like you create a text variable without a default value, it's blank. If you create like a number variable without a default value, I'm sorry, it's null. It doesn't have a value, it's null. But if you give it a default value of 0 and then another operation happens later on, something like 0 plus 2, it doesn't fail because 0 plus 2 equals 2. But if it is null, then null plus 2 is a problem. It might crash. Another thing to do is to perform conditional visibility to improve user experience from one side, and to like when something is not appearing on the screen, and then when the user enters something and then that other piece shows up, it is very clear to them that this is something that they need to look at next, at least. Combined with default values and validations in general, then this is helpful to get the data to be entered. Required fields, of course, if there is something that you require someone to populate, then make it required. And there is something nice about conditional visibility with required. If you make a field, a screen component required, but it is not appearing on the screen, the user doesn't have to populate it and they can move forward just fine. When the conditional visibility conditions are met, and then this field appears on the screen, then the user cannot move forward without populating this required field. So don't worry about making a field required if it is hidden. That's fine. If it's hidden, the user can move forward without it. And there is also, of course, the validate input. On every screen component, we can add validate input. After every screen, we can add a decision element to confirm that certain fields were populated, they were populated correctly. If they were not populated correctly, we can take them back to the same screen with a screen text that says, please populate this, or please correct this. If you use a validate input on the screen component itself, you can give them some error message above the field that they need to populate, or if they need to populate it correctly. There is also governor limits. We need to be mindful of governor limits to avoid errors. So try to use less DML, less create elements, less update elements, less delete elements. And the way this works is that if you need to create one record and then later in the flow you need to create another record, if they are of the same object, like create account and then later on create another account, then it's a good practice to just not create the first one yet and add it to a collection, and then not create the second one yet and add it to a collection, and put this towards the end of the flow. After you confirm that there is no more of these records, then you can create that collection with one DML instead. And the same concept applies to delete and update. The same thing with SoQL queries or get elements. Let's reduce them, and remember, the filter in the update element is also a SoQL query. So we need to reduce the number of filters that we use, and we need to reduce the number of get that we use. And it's a similar concept. If you need to get an account, and then later on in the flow you need to create get some other account, then it's better that you use one get and you get both of those accounts in the flow, and then you can use loops, filters, things like this to just extract the records that you need from that get without having to perform another SoQL query. Another very good practice and super important is to avoid DML or SoQL statements inside loops. This introduces two problems. The first problem is that you are approaching the governor limit. If you loop or you iterate through 150 records or 151 records, then and you perform a DML for each one of those, then you're gonna hit the DML limit and then it's going to crash. If you perform 100 get inside 100 iteration, then you're gonna hit the SoQL query and then the flow is going to crash. The other problem with this is CPU time. Loops and then like having a complex logic or DML statements or SoQL queries and things like this inside loops takes time. And when you take time, the more time you use, the more CPU time you use, the closer you become to the CPU time limit. And it's generally a good thing to reduce complexity. And in regards to governor limits in particular, let's not use DML or SoQL queries inside loops. One last thing in regards to governor limits is to basically reduce the or tighten. You need to tighten the conditions as much as possible in entry criteria, in get elements, in the filters of update elements. We need to tighten this as much as possible, because one of the there are some governor limits around how many records we return. Let's say, take SoQL for example. I think we can return 50,000 records. So if you get all accounts in the system or all contacts in the system, you might get more than 50,000. There might be 100,000 records in the system, which means the flow is going to crash. That's an error. To avoid that error, we need to add conditions to reduce that number from 100,000 to 50,000. And if you have 50,000 records, but you don't need all of them, you only need 25,000 of those, then reduce it even further. Keep adding all possible conditions that you can think of in get elements, in entry conditions, and in update elements. All right, complexities. Let's avoid complexities. I understand that there are some business processes out there that are complex. I mean, it's my humble opinion to even revisit the business process to simplify it. And it's also my humble opinion to revisit the data model and simplify it. I mean, we could definitely perform complex stuff in flows, but the whole idea is to make our lives, everyone's lives easier. And you do that by simplifying everything: the business process, the data model, and the flow. Maybe we can't control the business process, and maybe we can't control the data model, but we can control the flows. Things you can do in the flows is to avoid nesting in loops. So you can't avoid having a loop inside the loop. First of all, it's confusing. It confuses everyone, the person who is building it, and then the admin, like a future admin who's going to read through this. So try to avoid looping inside loops. And the second thing is complex formulas and complex decision elements, like if, and then like nested if inside an if inside an if inside an if. It's just too confusing. If you have two, then it's a better thing to just create multiple formulas instead of just like one big fat formulas. I'd rather avoid complex formulas altogether. And one other thing about nesting loops is the CPU time as well. Like this is like the biggest culprit in terms of CPU time limit. All right, one more thing. Let's separate concerns. And I'll show you like how this is also like helpful in a second. Let's display these two together. We could create a before save record triggered flow and an after save record triggered flow. Let's say that we are trying to perform a couple of things, like name a record and send an email. To name a record, to auto name a record, and to send an email, you can do both of these things in after save flow. But we didn't have to do the naming part in the after save flow. We could move that part only, the naming part, to a before save flow. I understand that we're gonna have two different flows, but remember, this is like fast, like I use this icon for that purpose, and it's actually called fast field updates because it doesn't go to the database and come back. So this is affecting CPU time, and this is affecting performance overall. Reducing the number of logic, the logic that's happening in after save flows. So, and let alone the concept of separation concerns. If you need to debug or troubleshoot something, having the logic separated in two different places. This flow is meant to do XYZ, and this flow is meant to do ABC. If you have a problem related to ABC, you only debug and troubleshoot ABC, and you don't have to worry about the second one. So the idea of separating concerns is good in terms of just like troubleshooting, and it's also good in terms of CPU time limit and avoiding errors overall. There are some things that you could achieve outside of the flow, and so it's always like it's always good to think what is the best tool for this, because if the best tool to achieve this is not flows, then it should be done with that tool, not with flows. Things like you could probably create a formula at the object level to get it done. You could use declarative lookup rollup summaries or the standard rollup summaries for master detailed relationships to perform some rollups instead of having to do that in flows. You could use user access policies to automatically grant permission sets to users. So these are like a couple of tools in which it would be better to use these tools instead of flows to get things done. And the last thing is more of a getting organized, and that is use subflows to reuse logic. Like how this is going to be helpful in terms of avoiding errors. If you build like the same logic in multiple flows, and then you just like forget that or you leave, at some point in the future, businesses change all the time. Business change all the time. At some point in the future, they're going to need to change something, to update something. So someone is going to update the logic in one flow and they're going to forget to update it in some other flow. So if you have one subflow that's being referenced in multiple flows, the admin at that point is going to update the subflow, and this is how you confirm that this got updated everywhere else. Otherwise, the place where it was not updated is going to crash. The last thing here, probably, I forget the number of slides, is to keep it dynamic. You do not want to hard code IDs, for example. A typical mistake that I've seen quite often is to hard code record type IDs. You don't have to do that. There is an object called record type. You can query that object. You query record type, you specify the S object. This is an opportunity record type. and then you give it the developer name, you query the record type, and then with the name, and then the retrieved ID is the one that you use, and instead of hard decoding the record type ID. So let's say you're creating an account and you need the business account record type. You query the business account record type, and then the ID from that get element, you use it into that create account record type ID equals that ID that we got earlier. And why you don't want to hard code IDs or record type IDs is because the IDs are different from one org, from one instance to another. If you pull a sandbox, the record type ID in the sandbox is different from the record type ID in the production environment. The flow is going to crash in the sandbox. If you built it the other way around, if you actually built the flow in the sandbox, then after you deploy the flow to production, it's going to crash in production because the ID is different in production. Another situation that happens is that an org might migrate to a new org altogether for whatever reason. In that case, the new org is going to have, even if you name the record type the same name, it's going to have a different ID. And one good practice to do as well is to store data outside flows. You could store data in custom settings or custom metadata or labels, and instead of storing them in the flow. And another benefit, like a benefit that this gives, is it makes it admin accessible, meaning that admins could add, update information from these places, or even from just like you could store some information in the objects itself, so records, actual records. Admins and other users could make edits without having to edit the flow itself. We've been talking about preventing errors for some time now. You see how much we can do to prevent the error from happening in the first place. Talk about user experience, like a user was sitting for 15 minutes, 30 minutes on a screen flow. If we took all of the measures around preventing errors, they are very likely to submit their screen flow successfully without problems. Handling errors means that when an error happens, what should happen next? You could display like a good looking error. So this is basically what's happening. Like instead of showing them a bad looking error, you're just showing them a good looking error. It makes it less, just a little bit less frustrating, but it remains frustrating. So it is important to prevent the error from happening in the first place. I mean, you could handle errors. You can do other things like log the error, but this is more of helpful for analysis and for admins. It's not exactly helpful for the end user. You could send an email. I'm not sure how helpful that is because admins get emails of errors anyway. So like I'm personally like not a very big fan of handling errors. I know it's important, but I give a lot of importance to preventing errors over handling errors. You could handle errors by, errors typically happen on the pink elements on get records, delete records, update records, and create records. You could click any of those elements, and after you click on it, you see add fault path, which allows you, after you click it, it's going to show this fault path. And this is when an error happens on that element, then take this path and do whatever logic that you add down here. Another problem with these fault paths is that you can't add fault paths to some other elements, like send email, like a screen element. So there are some places you can't even utilize that fault path. So preventing errors is a beast. Preventing errors has that much significance over handling errors.